is this is already in a factored form. This is a polynomial that's in a factored form. So the first thing you want to do is find the zeros. You can do the zeros in your head, but I want to explain kind of what we have here. When you look at this 3x, that's your first factor. The zeros come from each of these factors, okay? So the first factor is 3x. You can think of that as 3x minus 0 to the first. That 0 is 0, because if you let 3x equal 0, if you solve that equation, you get 0. Okay, the multiplicity is whatever that exponent is. That's the reason I wanted to write it that way, because all of these things have a multiplicity of 1, okay? So this is usually one of the ways that I check students on this. Give a 0, give its multiplicity. Okay, and remember what we learned last time. If the multiplicity is odd, do you remember which it is? Cross or touch? Cross, okay? You got to study that and you got to know that, okay? So that's going to cross the x-axis. Now the rest of them just do in your head. The next 0 is 8. It has a multiplicity of 1. Therefore, it also crosses. If the multiplicity is even, then it touches the x-axis. We did a couple of those last time. The next one is negative 10, has a multiplicity of 1. Therefore, that crosses the x-axis. And then the last one is 1/2, multiplicity 1, crosses like that. Okay? Yeah.
Why is it negative 10?
What's that?
Why is the 0?
Okay, because that on my paper, I've got x plus 10. And if you set that equal to 0, you get x equals negative 10. So it's kind of like the opposite. Just think of what makes that individual factor equal to 0. Okay? All right, now here's what you got to do next. And you got to put this together. The next thing you got to do is you got to figure out what the degree of this polynomial is. So if you multiplied it out, and please don't multiply it out. I see students sometimes do that on a test. You don't want to do that because it takes too long. It's just a total waste of your time. The degree is nothing more than all of these multiplicities added together. So you just go 1 plus 1 plus 1, so you have a degree of 4. So the next thing you got to know is, okay, I got a degree of 4. What are the two possibilities for the graph? It's either going to go up or it's going to go down, right? So your job now is to figure out which it is. The graph either does that or it does that, okay? So that you got to do that. To figure that out, what you do is you find the leading coefficient. I'll just abbreviate that, okay? I'll just use LC from now on. Okay, so watch this carefully. This is where students mess up more often on this problem than anywhere else from my experience of teaching this class. So let me show you what to do. I'm just going to write down the problem we have, and I want to show you what you need to do as a student. See, the idea is if you multiplied this all out, you would end up with an x to the 4th as your highest power. You're trying to find the number in front of x to the 4th. So this is what you got to do. Okay, so you would need to look at that. You need to look at this number. And then you need to look at that power and so forth. You always got to look at the coefficient of x and the multiplicity is important. So what you do is you do this. And I'll give you another example here in a minute that's a little bit better than this. So what you would do is you would just go, okay, 3, and don't worry about the x, just do 3 times 1 to the first times 1 to the first times 1 to the first. That's all that matters. If everything's factored, like if that was a negative 2, then you do negative 2 to that power, and so forth. Now, the point is, if you multiply that out, is that positive or negative?
Positive.
It's positive, okay? That's the whole point, is you have a positive leading coefficient. Therefore, how does the graph go? Does it open up or does it open down? Goes up, good. Okay, so now we know how that goes, all right? So you got to do that, okay? Now, the third thing you got to do is I'd like you to find the Y-intercept. And then what we're going to do is try to put together a graph on this. How do you find a Y-intercept? It's always the same. Let x equal 0. Good. Okay. So we just go, we do f of 0. You can do this in your head. You don't have to write all this out. You'll have 3 times 0 times 0 minus 8 times 0 plus 10 times 0 minus a half. I don't care if you do that in your head. What's the answer?
0.
0, exactly, because you got 0 times a bunch of stuff, right? Okay. So you have a Y-intercept of 0 like that. Okay, so see, what we've done is we've put everything together now. So now we're ready to draw a graph. So if you have a little room on your paper, just make a real small little graph somewhere. And I'll show you how this goes together now. Okay, so the next thing you need to do is you need to plot out all of these zeros. We have a 0 at 8. So that means I need to make my x-axis go out all the way out to 8. I have a 0 at negative 10. Okay, just as long as you got it labeled, you're okay. All right, and then that's good enough. So what we'll do is this. We have a 0 at 0, so I would put a dot there, and we determine, since the multiplicity is odd, that we cross. So I say put a C for cross. It'll help you put this together. Okay, then we have 0 at 8. It also crosses. We have a 0 at negative 10. It crosses. We have a 0 at a half. Okay, right in there. Okay, so that also crosses like that. Okay, and then what you do is we figured out the degrees even and the leading coefficients positive, so we know the graph goes like that at the endpoints. Okay, now what you got to do is just make sure that you can figure out roughly how it goes through those points. Okay, so is there any questions so far? Okay, all right, so here's what you're going to do. Okay, you're going to go straight through. Now, since you're crossing, you go through it. You got to turn directions. It doesn't matter where you turn directions. That's not the point of the problem. So change directions. You're going to cross. Then you're going to have to change directions again to cross there. Then you're going to have to change directions like that. So you have something that kind of looks like a W. Okay, that's the idea. So the idea with that is, based on the information I give you, once you figure out zeros, multiplicities, degree, leading coefficient, Y-intercept, you got it. Okay, tell me if that makes sense. Okay, because you definitely need to do that, for your exam next week. Okay, that's an absolute guarantee. Okay, because it's a great problem to test you over lots of things. Okay, if you didn't quite get that, we're going to do a couple of things similar to this that just add one step to this. Okay, all right. So let's go to the next page. And what we're going to do with this is we're still going to do the same thing. We're going to find the zeros. We're going to state whether the graph crosses the x-axis or touches, and find the intercepts. Okay, so the only thing that's different about this problem is it's not factored, right? So how do you start the factoring of this? You take x squared out. Good. So go ahead and take x squared out. You want to go ahead and do that. So you'd have x squared times 5x. 5 minus x. Thank you. Okay. So I got 5 minus x like that. Okay. All right. Now that's all you can do. Is just take that out. Okay, so we're going to kind of make a little chart here too, just like we just did. How many zeros do you have in this problem? 2. You have 2 factors, right? Okay, so x squared equals 0. That means you have a, not degree, that's not what I mean to put there. I mean to put 0. Okay, we need to figure out what the 2 zeros are, sorry. Okay, so the first 0 would be 0, right? What's its multiplicity? 2. Okay, how do you know? It's the exponent around that. See, this thing right here, that's the multiplicity. Okay, so that means you have a multiplicity of 2. Does it cross or touch? Touch. How do you know? Because it's even. Good. Okay, so you have to have all that down. You have to. Okay, what's the other 0? 5, right? 5 minus 5 is 0. Because what you're doing is you're looking at each factor and you're figuring out what causes that to be 0. So you have a 0 at 5. What's its multiplicity? There's nothing there. So it's 1. And does it touch or cross? Crosses. Good. Okay, everybody with me there? You have to start that way. Okay? So before we go through and get everything together now, what we need to do is we need to do these things. We need to figure out what the degree of this polynomial is. Okay? You can add the multiplicities, or just go back to the beginning. The highest power in that problem is 3, since it's already multiplied out. Now what that's going to tell you is the graph is either going to go like that, or it's going to go like this. You've already eliminated 2 possibilities. Those are the 2 possibilities right there. Okay? So next thing we got to do is we got to find the leading coefficient. The leading coefficient is, you can see what it is. What is the leading coefficient in this multiplied out form? It's the number in front of x to the third. What is that? -1, right? So you have a leading coefficient that's -1. That means that the graph is going to go like this. Okay, so now we've eliminated that and we know how it goes. Okay, so we have that. And then the next thing we want to do is we want to go ahead and do the y-intercept. Okay, well, the y-intercept goes like this. Okay, again, what you do is just replace all of the x's with 0. So you'd have f of 0 equals 5 times 0 squared minus 0 to the third, so that gives 0. Okay, and that's good enough. Okay, we've got everything that we need to do now to put this graph together. Okay, is there any questions? See, the only thing different about this is you got a factor. Okay, so let's go ahead and let's put together then a graph. Let's see if we can kind of figure out how this thing's going to go then. Okay, so what I'll have is we just draw a graph. We have a 0 at 5 and a 0 at 0. Okay, so I like to do this. I like to put a dot right on that x-intercept, T for touch, and let's see, we hit, nope, I'm wrong on that. That one was, 5 was the one that crossed. Okay, so that crosses. Then we had a 0 at 0, and that touched like that. And we have the y-intercept of 0 already. So the other thing is we determine, since the degree is 3 and the leading coefficient is negative, that this graph is, at the endpoints, is going to behave like that. Okay? All right, so now I'm ready to put everything together. All right, so here's how it's going to go. I'm going to go down there. Now, since I touch, what do I have to do? I got to change directions. I can't go through. Now what do I got to do? I got to change directions and cross. So there's your graph right there. Okay? And it's a very accurate graph, okay? It's got all the main key points of that problem that you need to have then, okay? All right, everybody okay? Okay, so you just got to factor that. Now this one right here, we're just going to solve this equation, but we're going to try to relate this a little bit to what we've been doing. So this has already got one side equals 0. You got a factor. How do you factor this thing? Take x squared out, so let's go ahead and do that. So you'll have x squared, and then you'll have x squared plus 6x minus 40 equals 0. Okay, now that does go further. I think that trinomial, this thing right here is going to factor further. So you'll have x squared, and you just got to figure out how this goes. The first term, of course, is x and x. Last term's 40. What are two numbers that multiply to give 40 that add up to 6? What?
4 and 10.
4 and 10, good. Okay, sometimes it takes a minute to figure that out. Okay, when you practice, you get where you see that a lot faster. So 10 and 4, and then the signs have to go plus 10 minus 4, because 10 minus 4 is the 6. That goes like that. Okay, so first of all, if you were solving this equation, what are the three answers to this problem? You want to do that in your head. What are they? 0, negative 10, 4. Okay, those are your answers. Now, part of what I want to do on this problem, though, is I want to just kind of relate this to the graphing that we just did. So I'm going to kind of show you how we would put together a graph on this then. Okay, so really what this means is we have a 0 at negative 10. That multiplicity on that is 1, so that means that crosses. We had another 0 at 4. I'll just put a dot there and label that 4. Multiplicity of 1 means we cross. We have a 0 at 0, but what's it going to do at 0? Touch or cross? Touch, because the multiplicity is even, right? So we have that. Okay, if you go back to the original problem, the degree is 4. The leading coefficient is the number in front of x to the 4th, so that's a positive. So what that means, if the leading coefficient's positive and it's a degree 4, it does this, right? Okay, that's one of the things we talked about in previous sections. So that means the graph of this thing goes like this. And here's roughly how it would go. You would go down, you would cross through that, you would have to change directions. Now, since you're touching, you'd have to change directions again, and then go like that. So if you put that in your graphing calculator, you would have something that looks like that, roughly. Okay, that's the idea. Okay? All right, everybody okay? Okay, all right, want to get all of those little pieces of that together when you're learning that then. So really on that one, you just got to solve, but I do want to relate that to the graph because that's important. Okay? Okay, one last thing I'm going to show you. This is real simple. On this next page here, this says that if you have a polynomial function, a turning point is just where it changes directions. Okay, so for instance, and you don't have to write this down, but if you had a graph like this, it would have 1, 2, 3, 4, 5 turning points. Okay, a turning point just means where that thing changes directions. Okay, but what this is just kind of a basic thing I want to show you. The maximum number of turning points is 1 less than the degree. Okay, it always is. Okay, and again, that's not the number of turning points, it's the maximum possible. So let me explain a couple of things on this, because you want to make sense of this. Okay, so let's say, for instance, that you had something like x to the 5th or something. You had an odd degree polynomial. Okay, and let's say we know that an odd degree polynomial, if the leading coefficient is positive, then the graph would go like this. So here's what you would get out of this. First of all, if your highest power is 5, that means you can have a max of 5 zeros, real zeros. That means that the most times you can touch the x-axis is 5. If it was 7, the most number of times you can touch the x-axis is 7, and so forth. So what would happen on this problem is, let's just put 5 dots here. 1, 2, 3, 4, 5. Now, if I connected this, and there's different ways I could connect this, if I'm just cross through these things, now let's count the turning points. 1, 2, 3, 4. That turned out to be 1 less, didn't it? In fact, it always will. So I'm going to do that one more time. Okay, all you got to know is the rule, but you can figure this out. Let's say that you had x to the 6th. So what that would mean is the most you can cross is 6 times. It doesn't mean that you're going to have 6 zeros. It just means you can't have more. Okay, and if it's an even power, okay, you might go like that. Same thing happens. Okay, if I just go through all those 6 zeros, now count them out, look what happens. 1, 2, 3, 4, 5. Does that make sense to you? Okay, so what will happen on that is that will tell you that's the maximum number of turning points you have. Now, doing these problems here is a breeze. Okay, what's the degree of number 24?
2.
So what's the maximum number of turning points? 1. There you go. So there's nothing to it. Okay, the next one, the degree on this, now, I want you to look at these things right here. That's what matters. Don't multiply it out. So if you have x to the 4th times x to the 4th times 2x, you have 2x to the 9th, right? Okay, so that means you have a degree of 9. Therefore, the maximum number of turning points is what? It's 8. Okay, now so you don't have to multiply that out and FOIL it. It's just take the highest powers of x and multiply them all together. Okay? Okay, same thing on this one. What do you think the degree is in your head?
4.
It's 4, right? Because what you're doing is you're multiplying the x's out. That's all that matters. That gives x to the 4th. Degree is 4. Therefore, the maximum number of turning points is 3. Okay, that's it. Okay? Does that make sense? Okay, all right. Okay, let me close.